ACL list. And this is how it will look like. You are creating multiple access lists. And the end of this, there is implicit deny. Means even if you will not mention this command, by default all traffic will be denied at the end. So these are very specific traffic. Either you want to permit or deny, whatever. If you don't mention this thing, in the end there is a implicit deny. I mean, it is blocking all traffic at the end. Okay, so I will give you the demo as well for this stateless firewall, and then you will have a better idea. So can you see packet tracer?
Yes.
Okay. So in this case, I'm just going to use one router, and I will keep it as simple as possible, because otherwise you will be confused. And I will use two PCs. Sorry. And I will choose this automatic connection to make the connection between computer to router, and then router to computer. So let's say the IP for this one is 192.168.1.1. And for this, we have 192.168.2.1. So these are both are on two different subnets. So we know from our previous study that if we want to make communicate between this computer to this computer, we need a router in between. So this is the router. So we will configure the router. So let's configure these IPs very quickly. Go to the desktop, IP configuration, 192.168.1.1, and then the subnet mask. Similarly, this one, desktop IP configuration and 192.168.2.1, and subnet mask is automatically appeared. Now in the router, just click on this router to go inside and click on the CLI, from where you will configure the brain of this router. So this the same system wizard we talked about. We do not want this, so hit no, and we are on a enable mode, user mode by the way, and we want to go into the enable mode. So as we know, we want to configure these interfaces. To reach these interfaces, we need to go into the global configuration mode, which is by typing configure terminal. Now I want to go into this fast Ethernet 0/0. So type interface fast Ethernet 0/0 and type IP address. Because this is from this subnet 1.1, so I will keep it in the same subnet. 192.168.1. Let's make it 100 for a default gateway, because I'm going to make this default gateway for this PC later on. And just type the subnet mask, hit enter, and write no shut. As you can see, the interface is in down mode. So typing no shut and enter, now it is up. So we can see from here as well, the link is up. Now we need to do the same thing for fast Ethernet 0/1 as well, but on a different subnet, which is for the 2. So 192.168, sorry, IP address 192.168.2.100, 255.255.255.0, which is the subnet for that. And do it no shut here as well. WR to write the configuration. So, you know, the label here as well, 192.168.1.100 for my left side and 192.168.2.100 for this network. So this is how, you know, if you label these everything, you have a better understanding from where you are moving to which destination. So at this moment, if I try to ping my default gateway or even the interface of this router, which is directly connected, and we know that it is directly connected, so it will be a pingable. As you can see, I can ping. And we discussed in our, you know, the last session that if I want to ping this leg of this router, I can, because this is on the same router. So this router has information about this one. So if I try to ping 2.100, and I guess the problem is, yep. Yeah. So Krista, can you tell me very quickly why it is not pinging right now to this? I'm coming from here and I try to ping this one.
Yeah, it should. It should. Because it's a router.
Mm-hmm. Okay, but you remember in the last lecture, we tried to ping and it worked.
Can I see the setting for that interface, please?
For the router?
Yes.
Okay. If I do show IP interface brief, you can see, sorry.
Yeah, I can see.
Okay, that's fine. It's not expanding, by the way. So this is for your fast Ethernet 0/0, which is 1.100. And for 0/1, we have 2.100. And it is up and up. So it means it is in a good state, by the way.
Yes. So do we have to do IP route or no?
For
see
where we will do IP route? Where we will do?
IP route?
On a router?
Yeah.
Okay, that's fine. And Haifa, if you can also add some into it.
Sorry, I'm slightly confused.
Okay, no problem. So the problem is, you know, the problem is we haven't mentioned about the default gateway. If I go to IP configuration, as you can see, it only knows about this one network. And I told you, if my computer wants to communicate with two networks, it has to go where?
To the gateway.
Default gateway, which is what? Which is 192.168.1.100. Got it?
Good.
Okay, so this time, if I try to do the same thing, it should work. And you can see it is working. So this is, I know this is a very confusing area, by the way, you know, but you need to figure it out. So same way we will do here as well. IP configuration, and we will do 192.168.2.100, which is the default gateway for this one to this. Means if this computer wants to communicate with this computer, which is on different subnet, of course, it will compare with this subnet with its own subnet. And if it is not matched, it will blindly send to the default gateway. Okay, so even from here as well, if I try to ping, first of all, my default gateway, which is 2.100, I can ping, and the other leg of this router, which is 1.100, and I can ping, we know that. But if I try to reach 1.1 from here all the way to here, what do you say? Will it work or no?
It will work?
Yes.
It will work? Okay, well, let's try.
Yes.
And from here, if I do, just a minute. First, confirm IP config ping 192.168.2.1. As you can see, it works because the router now have the knowledge about both legs. Okay, they know about the two network. Now they know about the one network. And from here, this computer knows that if I don't know about this two network, I just need to send to this router default gateway. Got it? Any confusion here until here? Any confusion?
Nope.
Okay, that's fine. So what we were talking about, we're talking about the ACL, access control list. So what is the scenario? I do not want this computer to ping this computer. So first of all, confirm. Let me close these things. So so if I ping 192.168.2.1 and we are confirmed that we can ping. If you want, we can do trace route. I think this is a command here, 192.168.2.1 or tracer, because packet tracer is a little bit different. Yep. So with the help of using the tracer command, we know that first it hit what? The default gateway, which is this one. Then it went to 2.1. Then it hop using this interface to this one and reach its destination. So the criteria is I want to block 1.1 pinging this device 2.1 using access control list. So click on this router. Go to the configuration terminal mode, because this is the global configuration. This is global command, by the way, access list. And type access list, and then you will see two kinds of access list. One is known as standard. This is also considered like STD and XTD, which is extended. Today, I will just discuss about the standard access list, not extended. Otherwise, you will be confused. And by the way, in CCNA, we have, a complete ACL lecture just on the ACLs. And we will be working on ACLs a lot in detail. And if you remember, we also use this ACL in the lab when we were doing a NAT. If you can recall, you remember if we were using ACLs in the NAT configuration as well. So these standards are from 1 to 99. And your router is intelligent enough. If you will type ACL command and will give the number like 1, it knows that it's talking about the standard access list, which is very basic access list. Extended, we can go further, dig deep into that. And if we want to block some like HTTP traffic, if we want to block some telnet traffic, if we want to block some other SSH traffic, something like that, we will use extended list. For the standard, this is just like layer 3 ACLs. We are just concerned about from source, from which source it is coming, and which that's it. It will not talk about the destination. In extended, we have source and destination as well. But the standard access list only know about the from where the traffic is coming. Okay. When I will configure, you will know about it. So access list, let's take first one because I want to configure the standard access list. And what I want to do, deny traffic or permit traffic. Let's make it deny. Okay, what is the source? It could be any or could be single host, or you can define the subnet as well. For example, if we have multiple computers here, and I don't want to specifically block this only host, I want to block this whole this subnet. So I can be more, I can use 192.168.1.0, which will represent this whole subnet. If I want to be more specific, I can use like 192.168.1.1 for this traffic only, but these will be allowed. So in this case, let's make it like the whole subnet. Okay. So for that, what you can do, 192.168.1.0, then space and put question mark. And you remember we talked about the inverse mask. This is inverse mask, wildcard bits. The proper subnet is like 255.255.255.0, but wildcard is inverse of that. If that is 255.255.255.0, inverse mask will be 0.0.0.255, which means in wildcard, which means look into these things. Just keep eye on these things. These are eyes, by the way. So I'm looking these. So I'm interested on these things. I don't care whatever comes after that. So this one is don't care. I don't care about this one. So here we are more specific, like access list. I want to deny this whole subnet. So what could be the wildcard for this one? If somebody can tell me or guess.
0.0.0.255.
Yes, because I'm only concerned about this network, this octet, this octet, and this octet. Whatever comes after that, I don't care. So it means I'm going to block this whole 192.168.1 network. Okay, and then do, and that's it. This is a very simple, and hit enter. So you have created one access list, which is denying this traffic. After that, whatever comes after that, I want to permit. Access list 1, permit any, and that's it. Means if we have some other subnets like 10 network, 172 net subnets, they will be allowed after that, because I want to just block this subnet only. If you want to see your configuration, go show access minus list, and it will show you whatever you did. And I told you after that there is 30 with implicit deny. Implicit deny means whatever comes after permitting will be denied. But you know, I am doing permitting everything, so that's why it will not go after that. But if I will not mention this one, here will be implicit deny. It means if I am running 172 subnet here, and then let's say one 10 network here, these all will also be blocked because of this implicit deny. Okay, now we need to apply this access list where on this interface when it is traffic is coming inside. So how we can do that? We need to go into fast Ethernet 0, and the command is basically access. Sorry, not particular to this interface because these are global commands. So we need to go into access. Just a minute. That is totally different. You know, when you are configuring as a global ACL, you will do access list. As a globally. So this is the global command. But if you want to deny the traffic specifically for this interface, you will go in that interface and the command is little bit different, which is start with the IP. So you also need to take this into account. Many people, you know, get confused, like I got confused. So this is the command is IP access group. What is the access list which I mentioned, which is number 1. You have to mention this one. And it is saying what is the flow of traffic, as the traffic coming inside or it is leaving this traffic. We know that the traffic from here, it is coming inside this interface. So you need to go IP access group 1 as it come inside and hit enter. And that's it. So now this access control list has been enabled on this one. This router will be looking into this subnet. As it hit this interface, it will block. Let's do it. So we need to go into this computer, go to the command prompt, and we can see the last time it was giving me reply. So let's try this one, ping this one. And now as you can see, the host is unreachable. It means our access list is working. So we cannot reach this destination anymore. Okay.
Now this could be done on a firewall too, right?
Yep. The same method we have almost.
Yep. Okay. So are you guys getting this whole concept of like how you can deny things from different levels? Like routers can do the same things. Firewalls can do the same thing. Or even when a single device have firewalls, is the firewall concept getting clear to you guys?
Yes.
Yes.
Okay, that's fine. This is known as stateless, by the way, because it doesn't keep the state of this ACL information inside table. So it is just looking into the source. That's it. And the other one is extended, that will take a look of source as well as the destination, because we can be more specific. We are going from 1.1 to, let's say, 2.100. We want to block just that flow. That comes in the extended list, and that, you know, we will cover in a ACL, CCNA topics.